In this video, I'm going to show you how to find all the prime numbers between 1 and 100. So prime numbers are numbers that have only two factors, 1 and itself. And all the other numbers, if they're not prime, they are composite numbers, meaning that they've got more than two factors. The only exception is 1, which is neither a prime number or a composite number. Now the reason for that, we'd have to look into the fundamental theorem of arithmetic, but we haven't got time for that, so let's just stick with knowing that 1 is neither prime nor composite. It's in a league of its own and we don't worry about it. We're going to stick with just the prime numbers. So in order to find the prime numbers, what we do is we have to work out which are the composite numbers, and then if we eliminate those, then we can then see what's left, and those numbers that are left are your prime numbers. And this process has got a lovely mathematical term called the sieve of Eratosthenes. Basically what that means is that they've got a sieve, put all the composite numbers through the big holes, and the numbers that are left over will be your prime numbers. Now normally when we're doing this method, we usually look at a 10 by 10 square, and then we'll go through all the times tables and eliminate all those times tables which would be factors of more than 2. However, I'm going to use a slightly different table. This one has got 6 columns. So with this table, you're going to realize it's so much easier to find all the prime numbers without having to worry about finding each timetable going along. It's quite time consuming. This method is going to speed things up so much. It's a little trick I really like, and I hope you love it too. So what we do, we start off with number 1. As I said before, 1 only has itself. There are no other numbers, so we don't have two factors, and therefore it's neither prime nor composite. So we can just eliminate 1 as being a prime number. The next number we have is 2. So 2 is a prime number because it has 1 and itself as factors. So here we will circle 2 to show our prime number. Now any even number after 2 will now have 2 as one of its factors, which means that we can now eliminate all the times tables that have 2 in it, which means all the even numbers can now be eliminated like so. The next number we have is 3. Now 3 does have 1 and itself, so 3 is a prime number and there are no other factors. Now any additional number in the 3 times table after 3 will now have 3 as one of its factors. So from 9 onwards, we can eliminate this column here. These are all in the 3 times table. The next number we have is 5. So we will have a look that factors of 5 are just 1 and 5. Again, 2 factors means that 5 is a prime number. And now any additional number after 5, which is in the 5 times table, will no longer be a prime number because they all have 5 as one of their factors. So we can now eliminate all the remaining 5 times table, which would mean 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, 85, 90, 95, 100. Then the next number we have is 7, and 7 is a prime number because it only has 1 and 7 as its factors. So we can circle 7. But any other number after 7 in the 7 times table will now have 7 as its factor, so we can eliminate those. So we will go this way. So we have 14, 21, 28, 35, 42, and 49, 56, 63, 70, 77, 84, and then 91, 98. And now that we've sieved out all the composite numbers, we are actually left with all the prime numbers. So here we have the remaining numbers. So now, so far we have 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47, 53, 59, 61, 67, 71, 73, 79, 83, 89 and 97. So these are all the prime numbers between 1 and 100. And it was so easy to find because we could just eliminate everything that we didn't need. It's a super quick and easy way. I hope you like this method. However, what if we need to find a prime number but we don't have a table to help us with? So let's get rid of this table. Off you go. Right, so we have now a blank sheet of paper and we need to find all the prime numbers. Well, we can start off with the ones that we already know. We already know that we have 2, 3, 5 and 7. Now, after that, things maybe get a little bit hazy, but this is where the magic happens. If we put 5 and 7 as subheadings for the moment, and then we'll start taking all the prime numbers from 5, and the way we do that is to add 6. This is the magic ingredient, just add 6. So we have 5 plus 6 is 11, and then it's 17, then 23, 29, 35, 41, 47, 53, 59, 65, 71, 77, 83, 89, 95. And obviously you can see that there are some numbers that are not prime, so we can just eliminate these. And we also know that 77 has a factor of 7 in this number, so that we can eliminate, but the rest are all prime. And then if we continue this with the 7, add 6, you get 13, 19, 25, 31, 37, 43, 49, 55, 61, 67, 73, 79, 85, 91, 97. And again, we can do some eliminating with anything that ends in a 5. And we also know that there's a factor of 7 in 91. And we know that 7 squared is 49. So that leaves us with all the other prime numbers. So provided you know one prime number, just keep adding 6. Eliminate the obvious ones that are not, but the rest will all be prime numbers. And this is a really fast way of locating your prime numbers. And if you enjoyed this video, don't forget to share, like and subscribe, and I'll see you in the next video. Bye!